Okay, alright. So bismillahirrahmanirrahim. Assalamualaikum semua. Welcome to kita panggil collaborative talk lah okay, daripada IPT, which is UMT. Okay, kita invite Dr. Muhammad Irwan bin Adiyanto. Okay, Dr. Irwan ni Malaysian, okay. Tapi muka dia macam like Korea, China macam tu tapi ada sikit macam Indonesia sikit belakang. So mix macam ni kot, apa kita dengar dia bercerita sikit. Alright, so basically untuk talk hari ni kita ada kita masih lagi menunggu pelajar-pelajar kita masuk. Okay, basically untuk ECS559 design RC, reinforced concrete design, okay, based on Eurocode tu. Okay, so kita baca dulu sedikit pengenalan Dr. Irwan. Sementara Dr. Irwan get ready dengan dia punya apa? Materials. Okay. Alright. So Dr. Irwan berumur, tiba-tiba umur. Okay, sorry. Itu rahsia. Nanti boleh PM tepi. Beliau adalah lecturer, senior lecturer di Faculty of Civil Engineering Technology. Okay, Civil Engineering Technology UMP, Pahang. Okay, Gambang. Alright. So beliau telah melanjutkan pelajaran degree di USM, okay, USM Malaysia, Master in Civil Engineering also USM juga, dan PhD Earthquake Engineering also from USM. Wah, Masya Allah. So memang pure USM lah ni Okay, so research field beliau ataupun research interest adalah earthquake engineering, seismic design to Eurocode 8, okay, repeated earthquake simulation, cyclic loading test, cost engineering, okay, structural work. Alright, so beliau banyaklah experience work, okay, professional ahli kepada IM, BM, okay, Board of Technologies. Okay, so sebelum kita serahkan kepada Dr. Irwan, okay, boleh tak saya mohon sama-sama kita semua sebelum kita mulakan sesi sama-sama bacakan Al-Fatihah. Alright, dan sedekahkan pahala Al-Fatihah tu untuk parents masing-masing insya-Allah hari Jumaat ni kan. Okay, so Al-Fatihah. Alright, so Dr. Irwan, the floor is yours. The session is yours. Okay, silakan.
Okay, sekejap ya.
Alright.
Saya share screen sekejap. Okay, boleh nampak tak?
Alhamdulillah, nampak.
Okey, clear ya.
Pelajar-pelajar mohon isi Google Form untuk lucky draw. So nanti kita boleh extract terus data sementara Dr. Irwan kita teruskan sesi ni. Dan juga jangan lupa klik attendance, okay? Alright, silakan Dr. Irwan.
Okay, bismillahirrahmanirrahim. Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wa hlul 'uqdatam min lisani yafqahu qawli. Bismillahirrahmanirrahim. Assalamualaikum. Good morning to all of you. Annyeonghaseyo. Okay, saya pertama sekali saya nak ucapkan terima kasih dan tahniah kepada UiTM Shah Alam, terutama Dr. Rozaina kerana beri peluang membuat jemputan untuk saya memberikan perkongsian melalui sesi collaborative teaching reinforced concrete design. Okay, topik yang diberi hari ini adalah column design dan terima kasih hari ini genap 2 minggu lepas buku saya dilancarkan. Buku saya bagi nama Kick Off sebagai tanda itu satu permulaan. Dan saya, tadi Dr. Rozaina cakap, USM adalah saya punya main base, tapi sekarang saya sudah di UMP dan UiTM adalah universiti dan institusi pertama yang jemput saya untuk membuat perkongsian berkenaan subjek RC Design, iaitu kolom design berdasarkan modul yang baru saya keluarkan. Okey, jadi saya tanpa buang masa saya teruskan. Okey, apa khabar semua? Saya harap semua student boleh dengar ya. Saya difahamkan subjek ini ada 200 lebih student. Attendance sampai 50 tak Dr. Rozaina sekarang ni?
Okey, sekarang ni sekejap ya. Kita ada sekarang 48 termasuk kita lah. InsyaAllah ada lagi yang akan datang tu.
Betul, tapi mungkin student ada yang berkongsi laptop dan device. Okay.
Yes, betul. Kalau ikutkan
Okay, so
kita punya tim ni, dari semalam total dalam 180 dah join dah. Cumanya untuk online ni masih lagi kita menunggulah kehadiran diorang, insyaAllah.
okay, insyaAllah. Tapi for your information, my students from UMP also join this lecture because they have the
Alhamdulillah.
material.
Alhamdulillah, right.
Thank
Thank you.
So thank you very much for UiTM for the opportunity. Okay, maybe this first time in history kita buat kelas sama-sama combine dua university. Okay, so for the column design, okay, let's take a look on the introductions where this material is, I adopt this material from my module, okay, which is the intensive tutorial module in reinforced concrete design 1. Okay, so introductions, what is a column? Column is mainly a vertical member in the structure. So it is mostly subjected to the compressions and is carrying load from the slab and the beam and then transfer the load down to the foundations. And column caters the action load and then the bending forces due to the continuity of the structure. Okay, but based on the clause 5.3.1 in bracket 7 in Eurocode 2, column is a compression member where the greater cross-sectional dimension does not exceed 4 times the smaller dimensions, where H is smaller or equal to 4 times of B, and height of the column is at least 3 times of the section depth. Okay, so this means that, let's say we have these cross sections. So this is our H, and this is our B. So the column is defined if these cross sections have this function dimension, which is H lesser than or equal to 4 times of B. If the H is greater than 4 times of B, kita tak boleh panggil dia sebagai column lagi, and it is known as the wall. And the height of the column is at least 3 times of the section depth. Let's say the depth is H is 500. So the column is, let's say this one from floor to floor. It must be the H, the height must be at least equal to 1,500 mm. Okay, which is 3 times of the H. Okay. So this is the classification of the columns, where we have the braced or unbraced columns. The braced columns is the columns or situations where the lateral loads are resisted by the shear walls or other form of bracings, which is capable of transmitting all horizontal loadings to the foundations. As we can see in the figure at this right of your screen, this is the plan view of a structural system, and this one is can be considered as the wall. Okay, and this is also the wall. For this type of key plan, the column can be considered as braced column. Okay, where it only consider the where the lateral load is resisted by the shear wall. But for the unbraced column is the situations where the lateral load are resisted by the frame actions of rigidly connected column, beam, and the slab. So this is the example of the key plan. And we have the slender column, which is like this one. Okay, slender or tall column is very long and thin column, and it will be the fail will be subjected by buckling. And another one is the non-slender column, which is also known as the short column. Okay, this is the figure, the short column, and the failure mode is by crushing. So this is the anatomy of a column. You can see the cross section, okay, major axis, minor axis, and the clear height from lower floor to the upper floor. And we can see that the column is attached to the beam at all 4 edges. Okay, this is beam, also beam, also beam, this is also beam. So this is the cross section, the elevation view, and we have draw the detailing of steel reinforcement letter. Okay. So this is the procedure to check the slenderness ratio of the column. Okay, this is the flow chart. Okay, or step by step. First of all, we calculate the clear height of the column, and then we calculate the moment of the inertia. You don't have to worry because this step we will try this step in tutorial number 1 later. Okay. And then we can calculate the effective length of a column. Then we proceed with the calculation of the slenderness ratio. This is the actual, and then we calculate the slenderness limit, and then we compare the slenderness limit to the slenderness ratio. If the slenderness ratio is greater than the limit, so the column is considered as slender or tall column. However, if the slenderness ratio is lower than or equal to the limit, the column is considered as the non-slender column. So the flowchart, you can refer to figure 7.3 in my module, which is in page 317. Okay, so this is the common failure modes of column, which is first of all is by the buckling. This one is, as mentioned before, is subjected to the tall column. And then this one is by the compression. You can see the figure, the real situation on site. The compression is subjected to the short column, and at the middle, okay, if the column is failed at the middle, this is strongly subjected to the shear failure. Saya minta maaf Dr. Rozaina, ya, saya punya tab nak conteng tu masalah pula. Tablet pen tak connect. But it's okay.
Oh, yeah.
So this one about the axial load and the bending moment. Okay, we have, okay, this one is in figure 7.4, which is in page 319 from the module. Okay, theoretically, okay, let's say we have, we want to calculate the bending moment and we want to calculate the axial load, which is a vertical axial load acting on column located at grid line B2. Okay, this one, what I label as C3 here. So we have to consider the slab tributary area. Okay, slab tributary area. So we can observe here that we have 4 number of slab. This one, 1, number 2, number 3, and number 4. 4 slab panels, okay, which attach on the beam, and then the beam also connected to the column. So this is the area, okay, quarter of the area from slab 1, and then quarter of the area from slab 3, quarter of the area from slab number 2, and then quarter of the area from slab number 4. Okay, which is half. Okay, let's say this one for slab number 1, length of A to B we divide by 2, so we get here the region, and then length of 1 to 2, grid line 1 to grid line 2 we divide by 2, so we get here the region. So this is the region where all the loading from this slab and the loading from the beam, okay, half of this beam and half of this beam will be transferred to the column labeled as C3. Boleh faham ke semua? And then from column slab number 2, for slab number 2, situation is similar. We divide the length of BC by 2, and we divide the length of grid line 1 to 2 also by 2. So the loading from this slab we transfer to the beam and then to the column. So this is what we call as the tributary area. Okay, and then let's say we want to consider the load, we want to calculate the axial load at column at grid line D1 here. So we divide 4 divided by 2. So here, let's say here, and then we divide from grid line 1 to 2, which is 4 divided by 2. So this is also here. So this is the loading that will be, this is the area, okay, where the loading from this area will be transferred to column located at D1. So that's why the column located, the actual load for column located at D1 is logically lower than the actual load for column located at B2 because lower tributary area. But it also depend on the slab thickness, depend on the, maybe this one we have brick wall, maybe we have brick wall here, and maybe this one is no brick wall, so it will influence the result. Okay, and then so this is about the bending moment. The bending moment in the column can be determined based on the maximum load combination, which is 1.35 GK. GK is the permanent load, permanent action, plus 1.5 QK. QK is the variable actions. And the minimum, okay, minimum is only consider the permanent action only on beams, okay, which are supported by the column. So let's say this is, we have beam number 1 and beam number 2. So beam number 1 will consider the maximum load combination, and beam number 2 will consider the minimum load combination. So we have to calculate, and the bending moment, the magnitude of bending moment at the upper this one. Let's say we have this is the cross section of the column. Okay, this is the floor. So this is your bending moment diagram. Sorry, I changed to red color. Okay, so this is the bending moment at the upper, and then this is at the lower. And then for the column at level 1, here is at the top. Okay, and here is at the bottom later. Okay, this is the important concept that you have to know, that the stiffness of beam and columns are strongly influencing the bending moment. Okay, then okay, this is about the bending orientations. Okay, for my module, I only cover the non-slender or short column only. There are 3 orientations of bending which has to be considered, which is the bend about the major axis. Okay, like this one, figure number 1, bend about the major axis, and then bend about the minor axis, and then the biaxial bending. Okay, when it bend about major axis, this is the H and this is the B. And then sometimes the column also will bend about the minor axis or YY. So the B and the H is changed. So the H will be the shortest and B will be the longest. And then usually column will bend by biaxial bending mode, where the column is subjected to bend about both Y and Z axis. Okay, so this is an example from this key plan. Okay, we can try together. The 3 cases. The case number A is biaxial bending. Case number B is bend about major axis, and case number 3 is bend about the minor axis. Okay, can I have somebody to help me? What is the case at A1? Case A, B, or C? Anybody? Anybody can try? The column will bend about A, B, or C. The case is A or B or C. Okay, my tab is all function now, alhamdulillah. Okay, the column will bend about A or B or C. Okay, let me give a clue. Okay, ada pen baru semangat kan? So this is a column in 3D. Okay, at the top of the column we have beam. This beam. Okay, I change the color. I like to play with color. Okay, this one. Okay, let's say this. Okay, this is the column, the beam. This beam will cause the column to bend. Okay, dia akan menyebabkan column to bend. Like this one. Okay, let's say this is the MZ. Okay, sorry, this is MY, okay, the major, minor, okay, because this one is shorter than this one. So dia akan bend, dia akan, kalau kita tengok daripada, if we have, if you can take a look, okay, from elevation view, this is the beam, and then the beam will cause the column to bend, okay, like this one. And then on the other hand, on the other side, we have another beam here. Okay, we have another beam here, and this beam will cause the column to bend around this axis. So at this for this situation, this case is known as biaxial bending. Okay, where we have the MZ and MY. Okay, so this case is usually occur for the column located at the corner of the building. So when I have somebody to help me to detect A1 is which case? Biaxial bending or uniaxial bending?
Biaxial.
Uniaxial? How about students from UMP? Any answer?
A,
For
Doctor.
column? So A, yes, good. A. Okay. May I know your name?
Aida,
Okay.
Doctor.
Siapa dia?
Aida.
Aida. Okay, thank you. Okay, so this one, this beam, let's say beam FB1, okay, FB1 here, will cause this column to bend about this one, this axis, and then column FB2 will cause this column to bend like this one. So we have biaxial bending. So another case with biaxial bending, okay, I mark it as green color, is C13 and also C4. And also, how about C12? C12 also biaxial, okay? And then how about C7? What do you think about C7? Is it biaxial or uniaxial? A, B, or C? Siapa yang setuju kalau saya katakan C7 adalah case A? Ada yang setuju tak kalau saya katakan ini adalah case A? Ahli-ahli masyarakat yang bersetuju, sila suarakan bersetuju.
Setuju.
Ahli-ahli yang tak bersetuju, sila kata tak setuju.
Tak
Tak setuju.
Tak setuju. Ahli-ahli yang tak tahu, sila kata tak tahu.
Tak tahu.
Jadi lebih ramai majoriti suara tak tahu. Jadi saya bagi tahu. Okay, so this one, you have to check the dimension of the beam. Okay, dimension lah. Okay, the length of the beam. So this beam, the length of this beam is about, color apa nak pakai? Okay, inilah. Okay, this beam, the length is 6,500 mm. Okay, and then this part of the beam, okay, another span is 5,000. Okay, let's say this beam is heavier than this beam. Let's say we have it depends actually, depend on the loading. So depend on the loading, the stiffness and so on. So this beam, the moment actually kalau beam tu dia sama panjang, the moment sama panjang dan sama loading dan sama size, this is the bend to this direction. Another beam will bend to this direction. Betul tak? Okay, let's say this is Z1 and this is MZ2. So if the MZ1 equal to MZ2, so this will be cancelled out. The moment will be cancelled out. Okay, so dia tak ada bending. But this one, for this case, the MZ2, the length of the span AB is greater. So logically, the MZ1 is greater than MZ2. Okay, so it will bend, right? Bend to this direction. And then we have FB4. For FB4, we have here, you have to consider the length here, which is 5,000, and another length is about 4,000. So it will bend to logically it will bend to both directions, which is here and here. So this is, let's say this is MY1, this one is MY2. So do you think MY1 greater or lesser than MY2? Let's say the loading is similar.
M2 greater than Y. MY.
M2 greater than Y, than 1. It shall be M1 greater than 2 because Y is longer span. So the bending will be larger. Okay, so the final bending shall be only 2. Okay, this MZ1, the red color, and then the blue color, this one. Okay, this is the bend to the sorry, red color. Okay, we bend to this direction, and then another one will bend to this direction. So this case is only can is also can be considered as the biaxial bending. Okay, which is case A. So how about the case B? So you have to look at the dimension of the column. So let's say we have the rectangular shape of the column, like this one. So we might have B and H. So let's say for the case of C6, okay, C6, we have I better erase. Okay, sebabnya saya padam ni sebab dia sedang berlalu. Okay, this one you have okay, you have FB3. So this one, the M1, MZ1. So MZ because this is H is larger than the B. Okay, this is MZ1. So and the dimension also larger than another part. So MZ1 is larger than MZ2. However, for the beam FB4, which is located vertical. Okay, you see the vertical beam here, the vertical beam. The dimension is equal 4,000 and 4,000. So, and let's say the loading is also similar. So we can assume that the moment, this is MY1 and this is MY2. MY1 equal to MY2. So the moment, the bending for this direction is cancelled out. So the bending is uniaxial bending and it will occur at the major axis, which is B. So C6 is B. Okay. So this one maybe, this is also maybe uniaxial. You can try later, this is uniaxial. Okay, and how about this one? C14. Can we have example of C, case number C? Maybe this one, C9. Okay, C9 is case C, this one. Because the major axis, okay, the moment due to major axis, this is MZ1. This is MZ2. The distance is equal to 5,000 and 4,000. So MZ1 cancelled out by MZ2. Okay, and then we have the moment from the MY. Okay, MY is from here, from this beam. From beam FB6 attached to FB9, we have moment here. So this is MY. And then this is the column orientation we see here. The column orientation is rectangular like this one. However, it will bend to the minor axis. This is minor axis, so MY. Okay, so you have to be careful about the H and B between major or minor axis because it will strongly influencing your calculation. Okay, so this is fastest or smartest way to remember. Okay, if the column is bent about the major axis, so the H is the longer side. So this one. Okay, let's say you have the rectangular column, you have H and you have B. So it will bend about the major axis. So the longer side is your H, and then the shorter side is your B. And then for the situation of my bend about minor axis, the H is the shorter side. Okay, be careful about this one because this is strongly influencing your calculation later. Okay, let's say I use this one. Okay, and the column, this is your, okay, let's say this is 400 and this is your 200. So the bending, let's say the bending is here. Okay, this is MY, bending about the minor axis. So 200 becomes your H, okay, shorter side. And then the 400 become your B. Okay. Any question up to now? No.
No question.
Okay, then this is the design procedure for uniaxial bending. Okay, you can refer the flow chart in page 321. Uniaxial bending is the bending about major or minor. Okay, that's why uni. Okay, just single direction. So this is the procedure. It's okay. You don't have to worry. We will do this one for tutorial 2. Okay, tutorial 2 or tutorial 2, tutorial 7.3. Okay, if you have the module, it's tutorial 7.3. And for UiTM students, if you print out the slide, a PDF given by Dr. Rozaina, you can try to do it. Okay, this is tutorial 2. Okay, I name it as tutorial 2. Okay, yang tu saya belanja lah. Okay, saya belanja daripada modul saya, but I have to remark with sample copy. Okay, because agreement between me and penerbit, so I cannot sell it. Okay. Okay, so this one is the design procedure. Until we calculate the design moment, we calculate the main reinforcement, and then we calculate we design the link. Okay, and then for the biaxial bending, okay, it's in page 322. This one is quite complicated, okay, because we have to design the main reinforcement and then we have to check the capacity against the biaxial bending. So we have to first of all, we have to calculate the design moment, and then we have to check the requirement for biaxial bending based on clause 5.8.9 in Eurocode 2. We have to fulfill all these two main requirements. Okay. If the slenderness ratio about Y divided by slenderness ratio about Z lesser than 2, and the word is N here, and also N. So, and also O and O. So we have to fulfill 1, 2, 3, 4, but 3 to 4 requirement. Either either the checking of biaxial bending is required or not. Okay, but usually it's required. Okay, so before I end this short lecture, can you please help me using your phone? Please help me to click the subscribe button of my new YouTube channel. Okay, you can type this channel to find the YouTube, and then please kindly click the subscribe button because I share all the tutorials from the module in this YouTube, so you can check the answer later. Okay, dah cuba?
Dah, sir.
Dah cuba? Okay, tiba-tiba naik pula saya punya ni. Sekejap ya. It's about 10 AM. Okay, good. Okay, terima kasih. Tiba-tiba naik saya punya subscribers. Okay, that's all for this lecture. After the short break, we can proceed with. I think we better proceed with tutorial 2 and 3 first, because tutorial 1 is quite long. So I hope I can make faster for tutorial 2 and 3. Okay? Okay, that's all, Dr. Rozaina, from the short lecture and introduction about column design.
All right. Thank you, Dr. Irwan. Okay, so we're going to have a short break. Sampai nak pergi toilet ke apa sekejap. Sebelum kita masuk tutorial. And sambil-sambil tu, okay, kita akan run kita punya lucky draw. So kita akan ada buat 2 session lucky draw. First sekarang, which is during break time. And then tengoklah beberapa lagi nanti akan ada di hujung. Okay, so sesiapa yang belum daftar link untuk kita punya lucky draw. Okay, saya akan share semula dalam kita punya chat box. Okay, kat situ ada link. You just sertakan nama dan juga nombor phone sahaja. So nanti kita akan contact untuk hadiah berikut. Hadiahnya adalah rahsia. Rahsia di hari Jumaat. Okay. Alright, thanks Dr. Irwan sekali lagi. Okay, so harap semua dah okay. Lebih kepada teori lah tadi kan dan sedikit contoh. Okay, so saya nak tengok sekejap saya akan share screen untuk kita punya lucky draw. Okay, alhamdulillah sekarang saya dah ada 74, okay, dah bertambah. Respons untuk pendaftaran lucky draw. Okay, kita akan tengok siapa yang kena. 75, dah bertambah. Okay, silakan. Okay, dan siapa yang belum klik attendance you future untuk student UiTM, please do so. Saya akan semak kejap lagi attendance tu dan akan keep on reminding you all regarding cepat naik. Dah 90 orang dah ni respons untuk lucky draw. Okay, cepat-cepat saya tunggu seminit lagi. Sebentar saya nak extract data ni semua. Okay ke so far? Boleh bersuara seorang tak wakil daripada grup saya random lah 6C3. Ada tak 6C3 sini?
Ada.
Masya Allah. Garang punya ya. 6B5? Ada tak? Grup 6B5? Hello? Okay, thank you Siti. 6R3? Hello?
Ada.
Okay,
Ada,
Masya Allah.
ada.
Thank you. Alright, thank you. Okay, so saya akan ambil dulu mana nama yang ada ni. Okay, yang tak sempat masuk, Masya Allah 103 dah respons. Alhamdulillah. Okay, so saya akan ambil dulu data ni. So kalau nama yang tak masuk lagi, kita akan masukkan dalam session yang akan datang lah. Okay, maksudnya session yang selepas ni. Okay, kita ada. Sekejap saya extract dulu. Bismillah. Hadiahnya rahsia InsyaAllah bermanfaat untuk semua. Untuk si penerima lah. Sekejap. Ini hadiah ni sebenarnya sponsor daripada hamba Allah. So, okay. Saya dah extract 106 nama. So, saya akan share screen. Bismillah. Nampak ke saya punya spin ni? Spinner saya nampak ke?
Nampak.
Nampak Doktor.
Mantap. Okay.
Nampak.
Okay, mari kita lihat siapa yang kena. Bismillahirrahmanirrahim. Siapa nak baca doa dulu sih? Saya baca doa. Nama kecil je nama nama dan juga nombor phone. Alright, so bismillahirrahmanirrahim. Mari kita lihat siapa yang kena. Allah. Alright, Masya Allah. Nur Atika. Nur Atika dari mana? UiTM ke? UMP ke?
UiTM.
UiTM. Okey, tanya. Okey, betul you hari ni. Okey,
Okay,
so
Doktor.
itu yang pertama. Dr. Nat masuk dah. Dr. Nat kita punya koordinator Dr. Irwan. Kita kenalkan. Okey, next. Alright, next kita remove Atika ya. Bukan remove daripada Microsoft Team. Kita remove daripada kita punya lucky draw je. Sebab kita bagi peluang pada yang lain. Okey, yang kedua untuk sesi yang pertama ni. Bismillahirrahmanirrahim. Siapakah yang seterusnya? Lelaki. Alright, alhamdulillah. Tanya dan Nish. Danish dari mana Danish? Ada tak kat sini?
InsyaAllah madam.
Shah Alam juga. Okay, Alhamdulillah. Okay, thank you. So, nak lagi ke? Saya rasa macam nak bagi lagi satu lah. Ataupun nanti saya bincang dengan yang penyumbang hadiah tu. Sebab ramai, kita ada ratio 100 lebih kan. Jadi semalam kita ada buat event juga. Okay, so semalam kita bagi 3 lucky draw. Hari ni kita bagi extra insyaAllah. Okay, satu lagi. Bismillahirrahmanirrahim. Siapa yang dapat? Rezeki siapa ni? Nur Fatin, Masya Allah. Okay, Nur Fatin Nabila. Saya kenal nama ni. Daripada UiTM Shah Alam kan?
Doktor.
Hello. Alright, okay, thank you. Okay, so cukup untuk sesi ni yang 3 orang. So nanti tengok nanti macam mana. Mungkin lagi 1 jam kita buat lagi and then di hujung nanti akan ada lagi. Okay, stay untuk aktiviti seterusnya. Okay, so Allahumma salli ala sayyidina Muhammad. Okay, so thank you. Kita boleh sambung ke Dr. Irwan?
Boleh.
Okay, Masya Allah. Alright, thank you. So kita terus sambung ke sesi tutorial. Okay, so please be focus. Tak faham, tanya. Terlebih faham, tolong confirmkan apa yang you faham tu. Takut dia salah faham. Takut overdose ke apa, okay. Okay, silakan.
Sekejap ya.
Alright. So saya harap semua orang semua student dah print out 3 tutorial yang kita bagi melalui lecture masing-masing supaya you all boleh bersama-sama buat, sediakan kalkulator masing-masing. Okay, so you feel it, you can feel it. Okay, tak faham terus tanya. Right.
Okay, saya share screen ya. Yang kedua. Okay, boleh nampak tak saya punya screen?
Boleh doktor.
Boleh
Boleh ya?
doktor.
Okay.
Boleh.
Itu macam-macam slow pula ni. Okay. Okay, minta maaf ya. Yang ini saya tak sempat ubah muka depan. Okay, sebab saya kena buat 4 slide untuk kelas hari ini. Very quite short notice juga ya. Daripada Sabtu lepas saya deal dengan Dr. Rozaina. Terus setuju. So 4 slide kena buat. Tak sempat muka depan. Ini standard template untuk YouTube sebenarnya. Okay, tak apa. Kita cuba teruskan. Kalau student UiTM, dia ada tutorial number 2. Okay, kalau student yang UMP yang ada modul, dia boleh buka muka surat 346. 346 untuk detail. Okay, so saya tak sempat remove ni, minta maaf. It's okay. So the banding. Okay, let's say the banding here is. Okay, so this one. Kita tak boleh ubah color ke tak? Ya, sorry. Saya punya tablet pen ni.
Habis kot.
Itulah dia. In the jam. Sekejap. Saya nak buka ni. Okey, 7.3.
So kita dah
Stop sharing sekejap.
178.
Stop sharing sekejap ni.
178 participant sekarang. Alhamdulillah. Akan ada lagi ni, sepatutnya 200 lebih dah sebab UiTM campur dengan Dr. Irwan punya student dan juga Dr. Muiz daripada Unimap pun join juga.
Sekejap dia pula.
Adakah student daripada Unimap sini yang dah join? Student Dr. Muiz?
Dia orang ada kelas apa Dr. Rozaina, tapi ada juga 1-2.
Oh ya ke?
Yang
Alright.
itu kebetulan dia orang ada kelas ganti rupanya, saya baru difahamkan tadi.
Oh,
Share.
okey. Tak apa, tak apa.
Tapi saya ada share jugalah apa info pada ni mungkin nanti apa dengan kepada koordinatornya tu.
Ya, saya restart laptop kejap. Kita rehat kejap juga 5 minutes.
Boleh, boleh, tak ada masalah. Okay, siapa nak pergi toilet ke apa? Nak minum air ke? Nak baca ayat sekejap ke? Silakan.
Agak dah habis. Tapi makan ayat kita.
Okey. Sementara menunggu Dr. Irwan dia restart laptop dia, kita berbesar hati untuk tambah lagi dua lucky draw untuk sesi sekarang. Janji akan ada lagi. Dah 5 dah ni kan. Okey. Kita nak tarik attention pelajar sebenarnya. Okey, nak baca doa silakan. Auzubillahi minasyaitonir rajim. Masya-Allah, semangat. Okey, hadiah adalah rahsia. Hadiah hari Jumaat daripada hamba Allah. Bismillahirrahmanirrahim. Silakan. Tengok siapa yang kena. Alright, Esther. Ada ke Esther? Sila bersuara.
Tahniah Hakim.
Kalau tak ada kita... sorry? Esther ada Hello? Ada tak ni? Kalau tak ada kita ambil yang lain. Kita nak yang online, yang ada di depan komputer. Esther bersuara please.
Rasanya tak ada.
Tak ada Okey, tak ada, kita tak ambil lah Kita ambil yang betul-betul berada depan skrin. Ke dia ada masalah tak boleh bercakap, dia punya speaker ada problem. Tolong type dekat sebelah chat box tu. Kalau you berada di bersama-sama kita di depan laptop. Tak ada mungkin dia pergi toilet ke pergi baju ayak kan. Pergi buat nestem ke apa kan. Ke pergi makan counter canai. Okay, so kita exclude lah kita remove. Okay, next. So tak ada, kita tak ambil kira lah Esther. Okay, next. Siapa lagi? Bismillahirrahmanirrahim. Okay, Nur Syafiqah ada ke?
Ada
Nur
doktor.
Syafiq.
Terima kasih.
Okay, ada. Okay, sama. Betul ke Nur Syafiqah tu ke siapa? Buktinya. Alright. Okay. Okay, thank you. Okay, satu lagi. Last. Harap Dr. Irwan dah bersedia lah kita terus. Okay, Nur Syafiqah. Okay, seterusnya. Sebab tadi Esther tak available. Okay, next. Alright, Khairul Azman. Okay, sudah saya ni. Ada tak? Khairul Azman ada? Sila bersuara atau munculkan diri anda di meeting chat. Tak ada, saya pas pada orang lain. Kita nak yang setia di depan komputer. Ataupun Khairul mungkin pergi toilet juga atau pergi bancu ayam tu naik kopi. Ada Khairul Azman?
Masa dah
Tak ada.
tamat.
Rasanya tak ada doktor.
Masa dah
Macam
tamat
lama.
Anis. Okey Anis faham. Okey, tak ada kita abaikan. Sorry Khairul, tak ada rezeki hari ni. Okey, remove. Okey, satu lagi untuk menggantikan Khairul punya hadiah tadi yang tak dituntut cik, tak dituntut. Bismillahirrahmanirrahim. Ya Allah bagilah aku. Ya Allah, ya Allah. Ya Allah. Allah. Sekali lagi. Tiup. Amboi. Moncong mulut tu meniup. Macamlah kena anginnya. Okey, Muhammad Faik ada tak? Faik Faik Syafil. Student saya juga ni. Faik ada Faik? Faik? Bersuara? Atau kau tak dapat bersuara, boleh letak dekat chat box. Saya di
Ada,
sini,
doktor,
doktor
ada.
cakap. Ada Mana satu? Ada? Alright, okay Faik. Okay, saya cap suara you. Okay. Okay, so Alhamdulillah. So settle, ada 6 hamba-hamba yang bertuah hari ini. Pagi ini. Nanti kita akan ada 6 ke 5, sorry 5 Okay, Dr. Irwan okay ke? Dah ready? Ke sudah berdoa ni? Bagi tak ready lah nak extra
Boleh,
lagi.
jom.
Janganlah macam tu. Jom Okay, jom.
Kita
Okay.
mulakan.
Alright, okay silakan.
Okay, boleh nampak ya skrin ni? Bismillah.
Boleh. Cantik tulisan dia.
Okay,
Cantik
dia nak kita edit tu punya apa?
Ah.
Kena ada logo, kena ada nilai ya. Okay.
Alright.
Okay, bismillahirrahmanirrahim. Okay, this is the question. Okay, as in page 346 in the module. Okay, the design the steel reinforcement for actually class during the examinations, the question will be given based on text, okay, or paragraph, okay, more than 6 or 7 sentences. Okay, so you must have the ability to extract all the important points. Okay, we are not going to give you the questions by the point. Okay, it's too easy for you. So for the degree level, the standard is by giving the question by the sentence or exactly in a paragraph. So design the steel reinforcement for 300 mm times 350 mm non-slender column. Okay, so this one is short column. So the concrete class is C30/37. Okay, the F means this one, FCK is not given directly. Okay, so may I know what is the value of FCK for this case?
30
okay, good. The unit?
Newton millimeter square, right?
Newton per millimeter square. Okay, good. Thank you. So means you are good in this one. So be careful. Sometimes the students don't know about this one. So they take 37 and then they maybe just assume as 25. Okay. So and then the yield strength of steel FIK is standard by 500 Newton per millimeter square. Okay. Then we must know the unit of Newton per millimeter square also equal to what unit? Do you know?
PA.
Sorry? Yes, M, megapascal.
PA.
Okay. So the column has effective length, LO is equal to 305,000 mm and will carry design axial load, the NED is equal to 1,500 kilonewton. Okay, and then the column is expected to bend about the major axis. Okay, so this is MZ. So where the bending moment at bottom and bending moment at top equal to 60 kilonewton and 120 kilonewton. So at the bottom is given as 60. So you must be able to read in sequence. Okay, so when the sentence mention the bending moment at bottom and bending moment at top, means the first value is belong to the bottom, which is 60 kilonewton, and then 120 kilonewton is belong to the top. So you must be careful about the sequence of the words using in this sentence. So you use the nominal cover, sinom equal to 30 millimeter, diameter of main reinforcement is equal to 16, and diameter of leg is equal to 8 millimeter. Okay, so I can proceed to the next slide. Okay, so we have to, first of all, we have to calculate the design moment based on this clause in Eurocode 2. For the non-slender column, the design moment, we have to choose between MO2 or M minimum. So the MO2 is equal to M plus NED times the EI. EI is the eccentricity. Okay, and then M maximum, so is between bottom and top. So we select between bottom. Okay, this one, if you can see, 60 kilonewton, and bottom we write down here. And then M maximum is 120. So we write down here. So we select the maximum. So what is the M now? I hope in this session I need more participation from students to give the answer. Okay?
120.
120.
Yes, good. It's
120.
120. The unit is kilonewton meter. Okay. So, and then EI is equal to L0 over 400, which is equal to 3,500 divided by 400. And may I have the answer? Use your calculator and we do it together.
8.75.
8.75.
The unit is important. So in this situation, you better make it in meter. Okay, you convert the unit in meter. Okay, and then you calculate the M2 because we want to determine this one, the M2. Okay, M2 is equal to M plus NED over EI. So that's why we need the M and we need the EI. So, okay, can you help me to calculate? M is equal to this one, 120 plus the NED is equal to 1,500 times the distance is 0.00875. So what is the value of M now?
2313.
Okay, 133. Okay, this is 23. Okay, this is 133.1. Okay, sama tak jawapan yang saya punya?
Sama.
Okay, so this one, so M minimum, the M minimum is equal to NED over E naught. So E naught is equal to, you refer to this clause in Eurocode, is equal to H over 30. So our H is, okay, what is the value of H for this case? Because this is major axis.
350.
So H is 350, this one, because this is the longer, and the B is the shorter, so it's 300. So 350, okay, 350 divided by 30, you will get 17.7. This one is lesser than 20 mm, so we need at least 20 mm. So we use E naught equal to 0.02 meter. Okay, we convert the unit to meter. And then the M minimum is equal to 1,500 times 0.02. Can you give me the answer? M
30.
minimum 30.
30
Yes, good.
kilonewton.
Thank you. M minimum is 30 kilonewton meter. So the MED, which is the design moment, we select between these two. Okay, we select between MO2, okay, or M minimum. So we write down here, this is the MO2, 133.1, and then M minimum is 30. So this is simple. The M maximum we can use equal to 133.1 kilonewton meter. So we will design based on this value of moment. Okay, any question of this procedure? I hope clear.
No, sir.
No question. Okay. Next procedure is procedure number 2, which is the design of main reinforcement. Okay, so this is the main reinforcement. This is our H. So the D. Okay, let's say this is our column cross section, and this is our main reinforcement. Okay, let's say 1, 2, 3, and 4. Okay, and then we shall have the, okay, let's say green color. This one is your link. Okay, the shear reinforcement or the confinement reinforcement. That's the apa istilah-istilah yang mesti you kuasai. Okay, this one is your link. Okay, so I hope you know how to calculate the D. So this is your D2. Okay, so D2 is equal to C nominal. This one is C nominal from the edge of the concrete to the edge of the first edge of the to the outer edge of the link, and then the diameter of link, and then the diameter of main bar divided by 2. Okay, can you give me the value of H D2? C nominal 30 plus 8 plus 16 over 2.
54.
40?
46.
Okay, good. It's 46 millimeter. So D2 over H. So 46 over H. 250 equal to D2 over H is very important. Sorry?
0.131.
Okay, good. So you can use 0.13. D2 over H is very important to determine which design chart you have to refer. Okay, because you have the design chart for D2 over H equal to 0.05, 0.10, 0.15, and 0.20. Okay, so each design chart will give you different result. So for this case, it's 0.13, so we may use design chart of 0.15. Okay, but before using the design chart, we have to determine the value of NED over BH FCK, and we have to determine the design moment over BH square FCK. That's why the B and the H is very important. Between the major and minor axis, you have to determine which one is B and which one is H. Either the longer side is H or the longer side is B. Okay, so may I know this one? The NED is equal to 1,500 times 10 to the power of 3. Remember, when you are dealing with the axial force for this type of calculation, you better you have to multiply by 10 to the power of 3 for unit conversion, and our B is equal to what value? I know the value of B.
300.
Okay, good. 300 times 350, and then the FCK, as mentioned earlier before, is 30. So what is the value here?
0.476. 0.476.
Okay, so we make it for 8. Okay, make 2 decimal places only for easier to use the design chart later. And then this one, the MED 133.1 times 10 to the power of 6. Okay, this is for bending moment. Okay, 6. And for the axial load is 3. Okay. So this will- Okay,
Man. Aku suka cium buat lima tu kat sana.
times 3 times.
Ya, dengan aku ya, Man.
So, what is the value?
0.12.
Sabar, ni tengah buat kerja.
Okay,
Abang.
0.12. Okay,
Masya
so these
Allah,
two
Masya
value
Allah.
is
So, dah anak
very
soleha.
Sir, termute lah.
okay. Boleh dengar? Terima kasih.
Boleh.
Okay, so we refer to this chart. Okay, sorry, tekan pula. Okay, so we have to know the value of n over b HFCK, which is 0.48 based on our calculation before, and then the m over bh square FCK. This one is based on equal to 0.12. So for on this chart, you have to, okay, this one, this is for 0.48, okay, between 0.4 to 0.5, you have to scale it properly, and then you draw a horizontal line, okay, the horizontal line, the blue color, and then for the bending moment, okay, you draw the red color vertically, okay, you have to scale down properly. So this one you can see 0.10, this one is 0.11, so this is 0.12. Here is 0.13, 14, and 15. So we use the 0.12 based on our calculation. And then we want to get the ratio of AS FYK over BHFCK, which is here. So the ratio is based on this curving line. Okay, so you find the intersection between the red and the blue color, which is here, and then you have to estimate. Okay, so this one, let's say this, I change the color. Okay, the yellow color here is for 0.3. Okay, and then I use a green color. Okay, the green color here is 0.4. So the ratio is located between 0.3 to 0.4. So you have to estimate the exact value. Based on my observation, anybody want to suggest the value? It's here, okay, located here. So this is, let's say this is 0.35. So let's say I use this one equal to 0.33. Okay. So the ratio of ASFYK divided by BHFCK is equal to 0.33. So we rearrange this equation to become like this one. So we bring down the value of 0.33, and then we have BHFCK and FYK. So we want to know the AS required. We solve this problem. We have to solve this equation. So may I know the value of AS required?
$2079.
Okay, good. Thank you. 2079 millimeter square. So we refer to the chart. Okay, so we refer to the table of steel reinforcement. Since our size diameter of steel reinforcement is 16, so we refer to the row of 16 only. Sorry, I changed the highlighter. So this one, okay, 16 only. So we refer to the. This is the. I hope you know how to refer to this chart, because you already learned from the beam design. Okay, this is the diameter 16. Sorry, color. Okay, 16 is the diameter, and this is the number of bars. So if we select 10, okay, we only can have 2011 mm square. It's still lesser than 2079. So what can you propose? Can we add another one? Maybe 10. This is
Another one.
add another one. Okay, this 10, and then another one is equal to 201 mm square. So can you total up? Simple. 2411 mm square. Okay, this is okay, 2411 mm square greater than that than the required, right? So it's okay. Theoretically, or based on calculation, is okay. But this is 10 plus 1 is equal to 11. You also have to think or consider the arrangement of the steel bar. Okay, so we try. So this is number 1. You have to arrange symmetrically, actually, as possible. 1, 2. Let's say you can arrange this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Mungkin macam tu. Kan? Because you nak apa? Asalkan cukup. Secara teori, secara calculation, yes. But you have to arrange symmetrically. Okay, sebaik-baiknya symmetry. Okay, let's say you tak suka yang susunan macam tu, you nak susunan macam ni. Okay, let's say this is the goalkeeper, 1. Okay, Argentina main macam mana? 4-3-3 ya? 2, 3, 4. The football, okay. Okay, maybe this is 4-3-3. This is Lionel Messi, okay. Okay, so this is also 11. Boleh tak you susun macam ni? Dari segi calculation dah okay, tapi dari segi practicality tak okay. Okay, so you have to, as engineer, you have to think how the workers will install the steel bar later. Okay, so let's say we have 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So it's quite rare. Okay, agak-agak janggal kalau kita ada column yang sebegini. So we better have another one, which is 12. Okay, so we use 12. So we if 12 H 16. So may I know the AS provided? Let's say 211 plus 402. Okay, plus 402. So the answer is 2413. Okay. Betul. Okay, good. So provided is 2413 mm square. So this is greater than the S required. So it's okay. And we have a better arrangement. Okay, so we have to check, okay, based on this clause 9.5.2 in bracket of 2 in Eurocode. We check this one, okay, and before we proceed, I'm so sorry because this error, this one shall be FYD. Okay, FYD. This is for steel, not for FCD is for concrete, but this one is for steel. If the steel is FYD. Okay, sorry for the typing error. Yeah, I hope I can revise the module soon. Maybe the second edition I can repair. Okay, so this one 0.1 and ED is 1,500. Okay, always times 10 to the power of 3 divided by FYD is 0.87 times FYK is 500. So what is the value? Anybody can help me give the answer?
$344.82.
Okay, so 345 mm square, and then 0.002 AC. AC is equal to BH. Okay. Okay, any answer?
210.
Okay, 210. So we select the maximum value, which is 345. Okay, so this one is our AS minimum, and then we check with the AS maximum AS provided. Okay, this one. So AS provided is greater than minimum, so it's okay. So how about the value of maximum?
4200.
Okay, 4200. Okay. So this one is greater than as provided. So it's okay. Okay, next. So this is the arrangement. Then this is the calculation, the comparison between provided and maximum and minimum. So this is the design of link. Okay, based on this clause in Eurocode 2, the minimum diameter of link shall be this one. This means that you have to select the maximum between the diameter of main divided by 4. Diameter of main is 16 divided by 4. Okay, so 16 divided by 4 actually this one. Okay, maximum between 16 divided by 4 is 4 and then 6 mm. So we have to select between 4 and 6. So you select maximum is 6 mm. So we propose 8 mm, which is greater than the minimum there. Okay, as the greater than 6 mm we select before. So it's okay. So we can proceed to the spacing. This one we select the minimum. Okay, make sure you know how to this page. Okay, refer this class. Okay, sorry, saya tak ingat page nama yang mana. Okay, which page? The exam, I believe this question will not be given. Okay, because it's already inside the code, so you must know. Okay, so 20 times diameter is 16, and then lesser dimension of column. So we have B equal to 300 and H equal to 350. So we select the lesser, which is 300, and in this case, we have to select the minimum. So minimum is okay between this is the result. Okay, 20 times 16 is 320, 300 and 400. So we select this one. Okay, so we can use H8 300 millimeter center to center. However, this is at the middle of the column. So at the section, okay, so this one is larger diameter. Okay, we select the 350 is the larger section. Okay, because we have rectangular column. This one is 300 and this one is 350. So at section 350 mm below and above the beam and at left joint, the S maximum is 0.6 SV. So 0.6 times 300 equal to
18.
18 or 180. Okay, 180. So we can propose H8175. Okay, we try to use the increment of every 25 mm. Okay, so we lower down to 175. Okay, this is the practical practice on site. Okay, so now we come to the detailing. You can make sure you know how to draw. This is the elevation view. And then this is the cross section. Okay, so I just get it from my sketching. So this one is we have four number of steel bar. Okay, this is the cross sections. Okay, and then we have this one is the 350. Okay, lower than the soffit of the upper beam, and then 350 mm. And then this is okay, this is 350. And then this is the lapping zone. Lapping zone, you can check to the code. Okay, usually we not provide lapping too close to the beam at the bottom, because this is in seismic design. We call it as the critical region. Okay, the critical region. So the lapping must be provided outside the critical region. So this is the, let's say the green color is this one. Green color. This is we call it as the starter bar. Okay. That's why we provide lapping. Okay, we provide this. This is we call starter bar from the bottom column. And then the reinforcement we calculated just now. Okay, let me use the red color. Okay, this is sorry, I usually sketch draw it properly by and complete with animation. Tapi tak sempat tak maaf banyak. Okay, so this is the, kita ada 4 nama kan? This one, 1, 2, 3, 4. Okay. So this is the link. The link is this one. Gunakan dia ni lah, purple. This is the link. Okay. The spacing is 175. Okay. This is also here at the lapping. And outside the lapping, at the middle, we can use larger spacing, which is 300 based on our calculation. But usually in practice, we use the spacing of 175 for all. Okay, from top, okay, from bottom to the top, we use the spacing of 175 all. Okay, this is to save the cost, but this is okay. We use a smaller spacing at the middle to save the cost because we can reduce the steel reinforcement. But in practice, for faster work or faster better supervision, we can provide the spacing, equal spacing. Okay, that's all for this tutorial. Congratulations. So those who have the module can try the exercise A1 and A2 in page 331 and 332. Okay. Okay, so thank you very much for watching. We can see you again in other tutorial. Okay, Rozaina, that's all for this tutorial.
Okay. Terima kasih. Masya Allah, Masya Allah. So far okay ke semua? Kita ada 194 online sekarang. Alhamdulillah. Okay. So selepas ni kita akan ada tutorial yang, ada 2 lagi tutorial, betul Dr. Irwan?
Betul, kita pergi ke tutorial 3 dulu.
Okay.
Sebab yang satu tu
So
agak
nak
panjang.
sambung yang satu agak panjang. Okay. So kita sambung ke tutorial yang ketiga dulu, betul?
Yes, betul. Bagi saya
Alright,
dalam 20
and
minit
then
dulu.
boleh. And then kita akan sebelum tutorial yang ketiga selepas tutorial tu baru kita akan buat another lucky draw. Alhamdulillah sumbangan telah bertambah, masya-Allah. Alhamdulillah ramai nak berinfak di hari Jumaat sebab partisipan kita dah 192 orang. So nanti kita akan buat 5 lagi lucky draw. Lepas tu kita sambung lagi tutorial yang panjang Dr. Irwan cakap tu, dan last kali nanti kita akan ada lagi 5. So total semua 15. Okay, rezeki you all hari ni ramai yang berinfak ni untuk hadiah lucky draw. Okay, kita bagi Dr. Irwan rehat sekejap. So sesiapa yang lain pun yang nak pergi toilet, okay, kita tak run lucky draw saya tak tipu. Sebab tadi yang tak dapat lucky draw tu dia pergi toilet rupanya. Dia PM saya. Tak apa. Nama dia masih ada dalam list. So nanti kita mana tahu ada rezeki sekejap lagi. Okay. So abang siap-siap nak pergi toilet pergi sekarang. Kita bagi 5 minit lah kot Dr. Irwan
Boleh.
Boleh? Okay,
Saya
5 minit.
edit slide, masukkan logo. Tadi tak masukkan
Okay,
logo.
5 minit dari sekarang. 10.45 kita start balik. Alright? So, have a great rest. 5 minutes. Okay, we will be back. Thank you.
أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. تبارك الذي بيده الملك وهو على كل شيء قدير. الذي خلق الموت والحياة ليبلوكم أيكم أحسن عملا وهو العزيز الغفور. الذي خلق 7 سماوات طباقا ما ترى في خلق الرحمن من تفاوت فارجع البصر هل ترى من فطور ثم ارجع البصر كرتين ينقلب إليك البصر خاسئا وهو حسير. ولقد زينا السماء الدنيا بمصابيح وجعلناها رجوما للشياطين وأعتدنا لهم عذاب السعير. وللذين كفروا بربهم عذاب جهنم وبئس المصير. إذا ألقوا فيها سمعوا لها شهيقا وهي تفور تكاد تميز من الغيظ كلما ألقي فيها فوج سألهم خزنتها ألم يأتكم نذير قالوا بلى قد جاءنا نذير فكذبنا وقلنا ما نزل الله من شيء إن أنتم إلا في ضلال كبير. وقالوا لو كنا نسمع أو نعقل ما كنا في أصحاب السعير.
Baik. Alright, so dengar suara saya. Okay, so kita alhamdulillah dah pendengarkan 10 ayat yang pertama surah Al-Mulk hari Jumaat hari ni kan. So Dr. Irwan dah ready untuk kita sambung ke next session?
Boleh, ini baru
Alhamdulillah.
separuh masa pertama ya. Belum
Yes,
bulan
yes.
sembilan
Nanti
ni
kita
kan.
akan ada masa kejuaraan ke Dr. Irwan?
Mungkin sampai penalti kot, macam Lionel Messi lah.
Masya Allah, penalti Okey, penalti Okey. Alright, so alhamdulillah, so kita sambung untuk tutorial seterusnya. Selepas tutorial tu nanti kita akan ada lagi 5 lucky draw dan kita akan sambung mungkin berehat sekejap 2-3 minit. Ini kita sambung ke tutorial yang sedikit panjang yang terakhir sebelum kita tamatkan sesi hari ini pukul 12 insya-Allah. Sekarang kita baru 10.49 masya-Allah. Okey, cik dah macam apa DJ radio dah rasa. Okey. Alright. Tadi kan saja nak ni. Tadi kita dengar apa nama ada suara yang dah terbuka speaker kan. Ada hamba Allah seorang student kita duduk. Kejap. Tengah kelas ni mak dia kata apa? Sekarang. Kan mak dia panggil. Okey. So tiba-tiba dia senyap. Mungkin dah kena tarik dengan mak dia. Okey, tak apa. Kalau ada sesiapa yang ada urusan yang emergency, maksud saya dalam short term lah kan, dalam masa 5 ke 10 minit, perlukan kalau mak ayah panggil perlukan apa-apa, please, sebab ingat mak panggil, kalau tak nyahut dosa kan satu, tapi tadi dia nyahut alhamdulillah. Okay, tunaikan dulu permintaan mak sebab ingat mak tu wajib kita tunaikan untuk kita sahut sebab menuntut ilmu ni sunat kan, so kita utamakan yang wajib dulu. Okay. Okay, so
It's okay, lagipun ni ada rakaman dan you pun dah subscribe
yes, betul. Saya nak bagi tahu betul
my
juga.
channel, so you tengok balik lah.
Sorry, saya nak betulkan statement saya tadi. Menuntut ilmu adalah wajib bagi setiap hamba-hamba Allah. Okay. So kita pandai-pandailah try arrange. So don't worry. Kita ada record, kita ada recorded. So nanti kita akan share balik untuk you all, especially untuk student-student nak buat final revision nanti kan sebelum final exam. Kita akan share. Saya akan download nanti. Okay? Alright, so kita teruskan. Silakan Dr. Irwan.
Terima kasih ya. Saya nak maklum kat sini ada juga Dr. Nubailah Abdul Hamid ni dari Politeknik Port Dickson. Dan juga ada Dr. Nadia Hussein dari UiTM. Okay,
Masya Allah ramainya.
Terima kasih.
Ini semua kawan-kawan kami Dr. Irwan Tim kita orang
Betul.
research earthquake sebenarnya. Okay. Alright.
Dr. Nadia dari UiTM, orang pertama yang saya perkenalkan. Modul ni belum cetak lagi, baru hantar ke penerbit, saya perkenalkan. Katanya berminat nak guna juga nanti, insya-Allah. Okey, cuma belum ada cetakan kedua lah. Tunggu cetakan kedua, insya-Allah. Okey, saya share yang tadi. Mana tadi? 7 point. Okey. Bismillah. Okey, dah boleh nampak dah saya punya screen.
Okay, dah almost. Okay, dah nampak.
Belum sikit-sikit. Okey, jom. Kita mulakan
Alright.
balik tutorial number 3, which is the non-slender column design bent about both axes. Tadi kita design about uni axis. Kali ini kita cuba design kedua-dua axis biaxial. Okey, tadi adalah case MZ. Kalau ada modul, you boleh buka tutorial 7.4 untuk y axis pula, minor axis. Okay, dan kali ini tutorial 7.5 sebenarnya dalam modul buku surat 354, dia adalah biaxial bending case. Okay, so this one you also have to extract the information from this long paragraph. Okay, the axial load NED is 2,200 kilonewton. Given the bending moment about z-axis, so mz is equal to 100 kilonewton meter. So this one 100 kilonewton meter. Oh sorry, tak ada ni. Okay, and then moment about y-axis, my is equal to 55 kilonewton meter. And then the effective length, okay, L or Z. This is kita belajar nanti dalam tutorial nombor 1. So 3.45 meter and L for Y equal to 3.60 meter. Okay. And then the slenderness ratio, this one we will learn in tutorial 1 later. 22.2, and slenderness ratio about z-axis is y-axis is equal to 24.7. Okay, design the column based on concrete class C30/37. So this means that our FCK is equal to 30 Newton per millimeter square. And then the main reinforcement is 20 mm, diameter of lead is 10 mm, C nominal is 30 mm. Okay. So we start with the first step is to calculate the design moment. Okay, the step by step is based on the flow chart which I share with you in the short lecture at the early of the session. Okay, so the imperfection moment we can calculate based on these equations. Okay, so the imperfection moment is equal to, okay, we do it together. So NED is equal to 2200, and then L naught of Z is equal to 3.45 divided by 4,000. So what is the imperfection moment about Z axis?
18.98.
Okay, we can use it as 19. And then how about the Y axis? 2.6. Okay.
19.8.
Okay, 20, okay. 90 point, okay. It's just a matter of decimal places. Okay, so the design moment, so this one, design moment for Z-axis is the given, okay, given mz plus the imperfection moment of Z-axis. So it's equal to, given is 100, so plus the imperfection moment is this one, okay, 19, so we bring it here. So it's equal to 119 kilonewton meter. Okay, so but for this one, this is actually MEDY. Okay, tadi dah Z, so this is typing error. Okay, typo. So very sorry for this mistake. So this one MZ, this actually is MY, and then this is MY. Okay, so the MY is equal to 55 plus the imperfection is 19.8. Okay, can I have the answer, please?
$74.8.
Okay, 74.8 kilonewton meter. So thank you. So this is the second step is to check the requirement of biaxial bending. Okay, so this is the, we have the, okay, for source of this figure is figure 5.8 from Eurocode 2. So this is the, let's say the column have offset. Okay, this is the center of the column, and then this is the center of the axial force. So this is the eccentricity of y-axis, and this is the eccentricity of z-axis. So we have to find the eccentricity. So moment of EDY we calculated before is 74.8 times 10 to the power of 6 divided by NED is 2,200 times 10 to the power of 3. So we can observe here that MDY here, this is, okay, about y-axis, this is MEDY. So it will create the eccentricity about z-axis. So that's why the equation is we are using MEDY. So may I have the answer?
3.4.
Okay, 34 millimeter. Okay, and then another one is this MEDZ 119 times 10 to the power of 6 divided by the NED. Okay, so what is the value?
54.
Very good, 54.1.
54.0.
Okay, it's okay. So we have to check these two ratio, 1 and 2. So this is N, okay? If these two situation fulfill, we don't have to check the biaxial bending. So can we do it together? So EY is equal to 54.1. H is, in this case, H is the longest, which is 400. Okay, So we divide by exact is 34 divided by 350. So what is the value here?
1.39.
Okay, so 1.39, which is greater than 0.2. So how about another one? Which is 34 divided by 350 divided by 54.1 divided by 400. Okay.
Zero point 70.
Okay, 0.72, which is greater than 0.2. So, according to the code, the limit must be lesser or greater than 0.2. So, if these two conditions already exceed the limit of 0.2, so we have to check. Yes, we have to check the biaxial bending. Okay, the conclusion is we have to check the biaxial bending. Okay, another checking is slenderness limit, the slenderness of y-axis, which is 24.7 divided by 22.2. How about this one?
1.11.
Okay, 1.11. This one is lesser than 2.0. Yes, limit by the code. The code limited the value should be 2.0 or lower. And then about this one, 22.2 divided by 24.7.
0.9.
0.9.
Okay, this is 0.9, also lesser than the limit. So for this requirement, we don't have to. Okay, we can ignore. Okay, we can ignore the biaxial bending. However, all these four requirements shall be fulfilled. So since this requirement concluded that we have to check the biaxial bending, so the final conclusion is to check or to ignore. Siapa yang cakap check dan siapa yang cakap we can ignore? Okay, we have to check actually. Okay, because these two requirements already concluded that we have to check. So walaupun yang dua ni tak perlu check, so dua requirement lagi kata check, so we have to check. Okay. Okay, so this one, we have to design the main reinforcement. Step number 3, we have to calculate the effective depth, which is H prime to the NB prime. So this is for the major axis, this is the H prime, and this for the minor axis, this is the B prime. So can I know the value of H prime and B prime? Okay, you just use this equation, and then you just have to replace for this B, you just use the B. With the H prime, you use the H. Okay, may I know the value of H prime? H. Okay, anybody can help me?
H prime 305.
305. Okay,
350.
350. Okay, and then the B prime.
300.
Okay, good. 300 mm. Okay, and then this is the M EDZ tadi 119 times 10 to the power of 6 divided by H prime 350, and then this is EDY is 70 something again, 74.8 times 10 to the power of 6 divided by B prime. So can you help me with your calculator, please?
340 kilonewton.
Okay, 340 kilonewton, and then another one is
249 kilonewton.
okay, 249 kilonewton. So we have to, okay, this one, please give your attention. So this one, you have to compare, okay, between these two ratio. Okay, MEDZ over H prime, you compare to the value of MEDY over B prime. So we can observe clearly here that 340 is greater. Okay, this one is 340 and this is 249. So MEDZ is greater than MEDY over B prime. So we select this equation, okay, to determine the value of design moment, final design moment. If, okay, let's say the value of this one is 400 kilonewton. Okay. So this one is greater than 340. So we use this equation. Okay. So this one you have to be careful. Then maybe you can you can check this one in Eurocode, or those who have the module you can check in the flowchart. Okay, which equation to choose. Okay, so NED over B HFCK. How about this one? Can you help me? Divided by B is 350. Okay, what is the value here?
0.52.
Okay, thank you. So the value of beta is equal to 1 minus NED. So because the beta will be used in the equation we select before. Okay, so this one is 1 minus 0.52. Okay, because this one is here actually. Okay. So what is the value of beta?
0.48.
0.48. Okay, because 1 minus 0.52. So and then the beta shall be greater than 0.3, and then the beta shall be lesser than or equal to 1.0. So 0.48 is here. Okay, it's in between, so it's okay. So we can use this equation. We can insert the value of M EDZ plus the beta 0.48. Then the H prime over B prime 350 divided by 300 times EDY, and EDY is 74.8 times 10 to the power 6. Okay, may I know the final answer? Okay, anybody can help me? Anybody from UMP or UiTM?
Takut salah, sir.
Oh, kalau salah mencuba lebih baik daripada tak salah tapi tak mencuba. Okey, cuba. Saya tak pernah salah baca Al-Quran sebab saya tak baca Al-Quran langsung. Wah, tu lagi teruk. Biar salah tak apa, yang penting you cuba. Okey. Berapa nilai dia?
160.89 kilonewton meter.
Okay, good. 160.89, so equal to 181. Okay, very close. Congratulations. Okay, how about the D2? C nominal plus the link. Berapa link tadi ya? 10 kan? Okay.
45.
45.
45.
45.
Yang betul ni 45.
45.
20. Main tu 10. Okay, so
50.
okay, 50. Okay, thank you. So D2 over H.
0.13.
0.13.
So this is 0.13. We can use chart of 0.15. So macam sama macam prosedur untuk yang sebelum ni unit action bending. So kita akan gunakan design chart juga. So we have to calculate this one, M PDZ. This one the letters. Okay, kita besarkan moment actually daripada 119 dan juga 748 kita besarkan lagi dengan factor of beta and H prime over B prime. So what is 1 times 10 to the power of 6. So divide by 300 times 350 square. FCK is 30. Okay.
Tutup mic, tutup mic.
Okay, saya dah mute kan. Sorry.
Okay, it's okay. Okay, any answer? Ratio dia?
0.146.
0.146. 0.146 ke 0.096.
0.146. Saya dapat juga.
Ada, okey, jawapan betul. Mungkin saya salah. Okey, 0.146. Okey, ada jawapan lain?
0.146.
Tak ada.
Sorry, bukan 300. Sorry, ini contoh tadi. Itu dia.
Salah
Lionel
H,
Messi.
sir.
H tu
This one, B dengan H kan. Sorry Lionel Messi dah cedera sikit nampaknya. Okay, 350 times 400. Okay, thank you. So answer?
0.096.
Okay, so we make it 0.1.
0.096.
Okay, so we can, kalau nak guna chart ni, saya nasihatkan up to 2 decimal places. Sebab nanti susah kalau nak terlampau banyak sangat. Sebab chart kita tu kecil je dia punya scale dia. Okay, so kita gunakan design chart tadi. Kita punya this one adalah 0. Berapa ya? This one is 0.10. Okay. And then yang tadi N over BH FCK 0.52. Okay. So kita boleh buat this one. Okay, this is our horizontal line. Okay, katalah okay, so this is I estimate 0.52 kat sini. And then 0.10 is here. Okay, ini mudahlah 0.10 clear. Okay, so anybody can estimate is between 0.2 to 0.3. Anybody can help me? Okay, good. Thank you. 0.28 or 29. So we take it to 9 lah besar. Okay. We take this one equal to 0.29. Sebab nanti dia akan bagi jumlah yang lebih besar kan. So dia lebih selamat lah. So 0.29. So the ratio is 0.29. And then kita settlekan as required. Times B. Jangan silap lagi macam tadi. Kali 400. Okay, but divide by 500. Okay.
2436.
436.
Okay, good. Thank you. 2436 millimeter square. So by referring to the table of steel reinforcement, which one to propose? Okay, you make sure if the question give you 20, so you refer yang 20. Okay. Kadang-kadang ada question bagi 20, you refer yang 16 atau yang besar lagi. Okay. So berapa kita nak propose? Sorry?
H20.
8H20. Okay, thank you. H20 and then the number is 8. because it will give us 2513. So we propose 8H20. Okay, the provided is 2513 millimeter square. So this one is greater than the required. So how to arrange the steel reinforcement? So let's say, of course, at the corner, 1, 2, 3, 4. Okay. This one boleh tak? 1, 2, another one, 7 dan yang ke 8. Okay, so it looks symmetrical. Okay, so we check the AS minimum. Okay. This one also a typing error. This shall be FYD. Okay, this is also FYD. Okay, so FYD is equal to 0.7 times 500. Okay.
506.
Okay, good. 506 mm square. So how about this one?
Two zero eight.
3,500.
3,500.
Salah.
Okay, 280. Okay, thank you. So which one we choose? 506 or 280?
280.
280.
506.
Okay, thank you.
506.
Thank you. Jawapan selamat, maybe. Terima kasih yang berhormat. So 506. Okay, we select the maximum value. Okay, so this one is lesser than as provided, so it's okay. So how about this one? The 0.04 times the BH.
5600.
Okay. 5,600. Okay, terlindung pula ya. Sorry. So dah selesai. Okay, so this one is greater than as provided. Nampak macam dah selesai lah kalau case yang uniaxial tadi. Tapi untuk biaxial, so we have to check for biaxial. After the design, we have to recheck. Okay, nanti kita buat. So step number 4 is design the link. The similar step as the previous tutorial. So we select the minimum diameter of link. So we must select between the maximum of 20/4 is 5 and 6. So the diameter of link must be maximum between these two. So we select 6. So minimum diameter is 6 mm. So in this case we propose 6 ke 10 diameter kita? Lupa pula. 10 kan? Okay, so this one shall be 10. Okay. So we propose 10 mm. This one is greater than or equal to 6 mm. So it's okay. So and then for the spacing, okay, 20 times the main diameter and then the lesser dimension of column. What is the lesser dimension of column?
350.
Okay, yes, good. 350. So we settle this calculation. So we have to select the minimum value between these three values. So obviously is 350. So we can use, sorry, this one is H10. Okay, H10, 350 millimeters center to center. This is at the middle of the column. Okay, so at section, this is the largest side of the column, which is 400 mm. Okay. So 0.6 SV is equal to
210.
okay 210. So what value we want to propose? The 10 is okay, but for practicality
200.
200. Yes, good. 200. So it must be in 25, 50, 75, 100. 125, 150, 200. So it will be easier for the construction workers to set this value on site because 25 mm is equal to 1 inch, okay, or close to 1 inch. So on site they use inch and feet. Okay, so this one is better. Okay, so this one is H10 actually. Okay, sorry for the typo. So, and then this is the checking of biaxial bending. Okay, this is the additional work if you are working with biaxial bending. So the area of steel reinforcement, so all means this is the all provided. So the z-axis also 8H20 because we provide this one. Okay, if you still remember my sketching, we provide symmetrical between the y and z-axis. So symmetrical. So the ASZ and ASY is similar. Okay. So D2Z over H is equal to D2 is equal to 50 over 400. And then D2Y is D2 is 50, also similar. Divide by 350. So can I have the answer?
Zero 0.125 or 213.
Oh, sorry. 0. This one, 0. Mana siapa ini? Okay, 0.150. So this one is 0.13. This one is 0.14. So both is close to 0.15. This is also close to 0.15. So we can use design chart of 0.15 again. Okay. Okay, we use again this design chart. Okay, the N over BHFCK we calculated before as equal to 0.52, and this one ASZ, so this is 2513 times FYK is 500. This is the reverse step actually. Okay. At the first time we are using the design chart, we want to calculate, we have the NED over BH FCK, and we have the M over BH square FCK, and we want to find this value, okay, the ratio of ASY FYK divided by BH FCK. But for this time, for checking, the given value is NED, this we know, and then we can calculate this value because we have the total area of S provided, and then we want to check this value actually. Okay, we want to check the moment, okay, the capacity of the moment provided if this steel reinforcement is installed. Okay, so BHFCK is times FCK. So any value here?
0.3.
0.3. Okay. Better use 2 decimal places only. Okay. So 0.3 is here. Let's say 0.3. I use the red color, right? So 0.3 is here. Okay. Exactly on this line. So we are very lucky. So you don't have to do the scaling and so on. So this is 0.3. And then this is 0.52. 0.52 is here. Okay, 0.52. So tadi this one. So at this intersection, we draw a line to the bottom. Let's go here. So we have the new value of M over BH square FCK. So can you tell me the value?
0.102.
Okay, 0.102 or I use the this one, sorry. Sepatutnya dia ke sini lagi ya. Sepatutnya dia ke sini lagi. So 0.103. Okay, it's okay. 0.103, we bring the value there. So we can calculate 0.103 over 350 times 400 square times 30. So what is the value of moment MRDZ? Any value?
6.13.
6.13.
Yeah.
Oh, sorry, this is not divide.
61.3.
Bukan divide, sorry. Oh, tak nampak ni. Kali ni, besok kali lah. Kali 3650 kali 400 square kali dengan 330. Macam tu. The equation ni, saya tak nampak sebab ada yang lindung.
173.
173 kilometer meter.
Ni. Okay, sorry ya. Tak maaf banyak. Okay, so 173 kilometer meter. Okay, thank you. So, the next step is calculate. This is MRDZ. MR means moment resistance or the capacity for Z-axis. Okay. And then this is the SYK. Okay, we calculate the SYK. Okay, the value is similar to 500 times 500 because our arrangement is symmetrical. So the answer will be similar. So you don't have to calculate twice actually. Okay. So okay, this one is 0.3 tadi, and then the NED over BHFCK 0.52. So you use the similar chart pun tak payah guna chart pun sebab kita nilai dia sama. So automatically 0.103 and then tak payah kira pun automatic dia punya nilai sama dengan 173 km square. Okay. So kita teruskan ke NRD pula. 0.567 times the FCK 50 BH, this one 350 times 400 and plus 0.87 times 500 times AS is the overall 2513. Okay, the answer
3.47.
Okay, 3475 kilometer. Okay, so we calculate the ratio of NED over NRED. This is the capacity, okay? This is the capacity of axial force. And so this is NED, this is the demand. And this one, the NRED is this is the supply. Okay, so supply and demand. Okay, divided by 3475. What is the ratio?
0.63.
Okay, 0.63. Thank you. So we must use the interpolation. Okay, we have to refer to this table, which is table 7. This table is in page 75. Okay, in the module, the table is table 7.3. Okay, so the value of the ratio of NED over NRED, so NED over NRD, sorry, is 0.63. Okay, in between, so you do the interpolation. Later you can do, I give you the answer, is equal to 1.44. Okay, so the imperfection, this is the final step. The imperfections are only considered in one direction, which is the most unfavorable effect. So the MEDZ, we can choose the maximum one tadi, yang 119. And then MEDY, we can select the maximum, okay, which is the original value, 55. Okay, so we can try to settle this equation, 119 divided by MRDZ, okay, 173 yang kita kira tadi, and then 8 is equal to 1.44. plus 55 divided by 173. Okay, 1.44. So make sure this one is lesser than or equal to 1.0. So boleh saya tahu jawapan dia?
Zero point
0.78.
Okay, good. 0.78. So this is lesser than 1.0. So the design is okay. So it passed. So what will happen if this value is greater than 1.0? So the design is not okay. So you have to maybe propose, maybe you have to redesign by propose other size, okay, other diameter of main bar, and so you can get other arrangement of the main bar. Okay, so you have to recheck your calculation. Okay, so this is the detailing. On detailing part, okay, sorry saya tak sempat siapkan lagi yang ni. Tapi detailing tu just sama macam yang tadi. So you have to consider the lapping from the bottom column. Okay. Okay, the starter bar from the bottom column. And then this is your reinforcement. Okay, dia jadi starter bar pula ke atas ni. Okay, and then section pun buat senang je. Okay, make sure you kena completekan juga dengan you punya ni. Sorry. So complete. Sorry. Okay, this one, okay, this is the link. Okay, so the size, okay, 350 times 400, and then the main bar is equal to 8H20, and then the link is, you can take a H10 200. So yang 200 tu kat sini, 1 sampai kat lapping settle. So dia punya, this one is H10 200. Kat bawah ni pun sama. Okay, this one sama H10 200. Dan dekat atas, yang kat tengah-tengah at the middle, you can take larger spacing, which is H10 350 tadi. Okay? Any question?
No, sir.
Okay, thank you. Tahan Jumaat ya. Nasi kambing habis ni Kang. Okay, so thank you very much. If you have the module, you can try page 360. Similar cases but different value, so you can be more familiar with the step-by-step. Okay, thank you very much for watching. All the best. Thank you. Okay, Dr. Rozaina, that's all.
Alright, terima kasih Dr. Irwan. Alhamdulillah. Okay, so Dr. Irwan, kita ada satu lagi tutorial kan? Betul?
Betul.
Okay. So sekarang dah 11.32. So lebih kurang 30 minit lagi ke pukul 12. Almost 30 minit lah. So macam mana rasa sempat tak 30 minit tu? Paling panjang kan
boleh buat dengan syarat saya bagi jawapan dan step by step tu student akan isi untuk check question. Isi sendiri.
Boleh?
So
boleh.
saya tak perlu tunggu student tekan calculator lagi dah. Okay.
Alright. Okay, boleh. Alright.
Lionel Messi pun dah tak nampak tiang gol kat mana.
Betul-betul. Masa kecerahan sekarang. Sebelum kita pergi ke penalti ya. Sebab rasanya kalkulator dia orang pun dah bateri dah weak tu nak kena charge tu.
Okay. Kan nasi kambing habis.
So nak sambung terus ke? Kita break kejap 2-3 minit je bagi Dr. Irwan minum air sikit. Dan kita run 5 ke nak proceed terus?
Bagi saya seminit dulu sekejap, nak bangun sekejap.
Okey, alright. Alah, sian dia. Okey, kita bagi dia, Dr. Balkis. Dekat sini kita punya seorang lagi lecturer yang mengajar ECS559, Dr. Irwan. Ini kita ada Dr. Balkis.
Okey.
Okey,
Ada 4 orang ya?
Okey. Kita ada, 4 orang. Seorang lagi Dr. Arwan. Arwan dengan Irwan. PM Dr. Arwan, so beliau tak dapat join kita hari ini. Ada urusan. Okey, so kita pergi kepada kita punya, apa nama? Semua tertunggu-tunggu Okey, kita punya lucky draw 5 kita ambil. Sementara Dr. Irwan minum ayak sikit, bagi dia betul-betulkan suara dia. Tak mau pitching lari lagi. Okey, Bismillahirrahmanirrahim. Saya share screen ya. Okey. So far saya dah update, kita tengok list yang the latest sampai terkini tadi dalam 5 minit lepas. List pelajar-pelajar yang isi Google Form lah untuk lucky draw. Saya share screen. Okay. Alright, so untuk pengetahuan, nama yang dah dapat 5 orang tadi tu kita dah remove daripada list. Auto remove tadi sebenarnya. Okay. So, ready semua? Sekarang yang kat sini ada 138 nama untuk pengetahuan lah. Daripada 138 ni kita akan ambil 5 lagi. Bismillahirrahmanirrahim. Alright, Aina Akila. Pun macam kenal ni. Ada ke Aina? Aina ada? Kalau tak ada, kita bagi yang pada yang lain. Ada tak?
Dah gerak di masjid tu.
Pergi masjid?
Masa tamat.
Masjid mana tu?
Masa tamat.
Okey, masa tamat. Okey, sokong semua. Tadi Aina Akila saya tahu ada dekat dalam chat.
Ada
chat room?
dalam list participant ada, Rozaina.
Tak, kita cuba ambil yang ada di depan komputer.
Okey.
Betul.
Right.
Thank you. Okey. So tak ada so kita bagi peluang yang lain. Sorry saya share sekali lagi sebab tadi room pun nak klik suara. Apa sound? Alright, sekali lagi. So kita exclude. Tadi saya ada exclude nama Akila tadi. Okay, tak apa, next. Okay, Rabiatul ada? Ada ke bersuara, please?
Ada, Doktor.
Alright, Alhamdulillah. Okay, so saya remove dah ada. Okay, sekejap. So saya simpan dulu. Okay. So next, sekejap Okay, next. Bismillahirrahmanirrahim. Megat Hakimi. Ada ke Megat Hakimi? Satu, Megat Hakimi 2.
Share laptop ni.
Sorry?
Kalau share laptop ni.
Oh, share laptop boleh tak ada masalah. Okay, ada Okay. Megat Hakimi ada. Alright, so saya remove. Okay, next. Bismillahirrahmanirrahim. Oh, dia punya gelas seronok. Masya Allah, rezeki. Okay, next. Muhammad Syazwan ada? Muhammad Syazwan 1. Muhammad Syazwan 2.
Ada, betul.
Alright, okay, saya remove dari lucky draw bukan daripada Microsoft Team. Okay, so berapa lagi? So 1, 2, 3. Aina Akila, Rabiatul dengan Syazwan Megat Hakimi. Okay, 4. Satu lagi, last untuk sesi ni. Bismillahirrahmanirrahim. Cepat tiup sikit. Kut nak kena. Ada satu tempat kosong lah. Okay. Okay, Muhammad Azim Rizal. Ada tak Azim Rizal? 1, Azim 2, Rizal 3, Azman 4. Tak ada Muhammad Azim Rizal Azman? Ataupun dekat chat box ada ke yang bersuara? Saya tak tengok chat box. Tak ada Okay. Okay, last. Okay, kita close. Next So, kita close. Next. Bismillahirrahmanirrahim.
Doktor, yang tadi ada dekat chat box.
Ada. Kat chat box ada?
Ada.
Mana? Oh, okay. Okay, tak apa. Okay, kita terima. Saya tak perasan tadi. Boleh, tak ada masalah. Sudah kita dah buat ni kan? Okay, tak apa. Syazwani Samingan pun, ni sudah kelas saya juga ni. Okay, so kita accept layan ni tak apa. Itu rezeki. So, kita remove. Okay, so settle. Kali ni ada 6. Itulah namanya rezeki. Kalau ada rezeki tak ke mana kan? Okay, saya stop. Sesi yang ni ada 6 orang. Saya dah record. Okay, kita sambung. Boleh Dr. Irwan?
Okay, boleh. Jom.
Okay, boleh. Jom. Saya stop sharing. Alright, silakan.
Okay, dah nampak slide
Okay, nampak.
Okay, jom kita mulakan tutorial 1 Bismillahirrahmanirrahim, which is to check either the column is slender or short column. Okay, Bismillahirrahmanirrahim. This is the question which is actually from tutorial 7.1 in the module. You can check in student yang ada modul boleh check muka surat 324. Okay, so this is also typo. Tak betulkan lagi. Okay, so this is the, you have to read lah the action load and then the moment at major axis, moment at minor axis. Okay, this is quite tricky, but it's okay. Saya bagi jawapan dan yang you use the printed. Okay, sebab Dr. Rozaina dah bagi yang PDF, so you can print lagi lah kalau you nak buat lagi sekali. So this one, the plan view. So kita nak check this one. Okay, sorry, this is a screenshot, jadi saya tak nampak. Tapi kalau you beli modul, insyaAllah nampak dengan jelas. Okay, so this is the column yang kita nak check. So this is the cross section. So given in this question, and this is FB, okay, floor beam, and this is the GB. Okay, in this case, the size of FB equal to GB. So the stiffness are similar. Okay, so this one is attached by FB4 and this FB5. Okay. Okay, so kat sini kita anatomy dia lebih jelas. Okay, this is 250, this one is 375, and then the MZ and MY ada nanti at bottom and top. Okay, based on the paragraph yang kita baca tadi. So this one is the total height. Okay, from top of the beam to the top of the beam here is 3,500 mm. Okay, so this is FB, this one, okay, the red color is FB5, this is GB5, okay, same color because the similar size. So this one is green color is FB4, okay, the size is smaller. Okay, FB4, the size is 200 times 450, and then the FB5 is 200 times 550. Okay, so we have to check the slenderness on both Z and Y direction. Okay, so see, this is the column, this is the position of the beam. Okay, so this one sama lagi. Okay, so this is ni dia, kita nak check yang column, this column actually. Okay. So Z-axis MO2 is equal to 85. So you can write down the answer. Okay, this is from the text, okay, from the paragraph in the question. So, and MO1, okay, MO2 is at the top and MO1 is at the bottom. So we mark as negative because different direction. Okay. For y-axis, the answer is MO2 is 60 and MO1 is negative 25 kilometer meter. Okay. And another solution is okay, we have to calculate the clear height. Okay, the z-axis, the clear height is floor-to-floor height, which is 3500 minus the beam depth. In z-axis here, z-axis is attached to the FB5. As I mentioned before, FB5 is 200 times 550. So we have to minus by 550. So the total clear length is equal to 2950 mm. And then for the y-axis, the clear height is equal to, this is 475. Yeah. This is 475. Actually, the FB4 is 200 times 475. Okay. So this is, so the clear height is 3025 mm. Okay. So the next step is to, okay, the beam. Okay, the beam bending about major axis is FB5. So we have here the blue color is FB5 and here. Okay, because this is the color we have considered. So this is span number 1. Span number 1, and this is span number 2. So span number 1, the length is equal to here. This is 6,500. It is very, very clear in the module. And then this is 5,000 mm for span number 2. So bending about the binding axis, we have FB4, which is green color. I mark here, and this the span number 1 is here. This is span number 1, and this is span number 2. Span number 1 equal to 4,500, and span number 2 is equal to 5,200 mm. Okay. So we have to calculate the moment of inertia for the column. So for the bend about the major axis, B is equal to 250, and H is the longer side, which is 375 mm. So the moment of inertia, you can use this equation. You can insert the B and H. So it's equal to 1.1 times 10 to the power of 9 millimeter. Okay. Then bend about minor axis. So B is 375 and H equal to 250. Okay, for the minor axis, H always the shorter side. Okay, so we can calculate the inertia about y-axis. The answer is equal to 4.9 times 10 to the power of 8. Okay, and then for the beam, okay, you can use this one. This is clear. This B and this H. Okay, this is the answer. And for FB4, this is the answer. Okay, sempat salin tak?
Sempat.
Boleh ya? Okay. Okay, good. Okay, next, the stiffness. The stiffness, by using this equation, you masukkan saja tadi. Okay, IZZ, okay, 1.1 times 10 to the power of 9. E, you just remain the value of E. Okay. And then IZ, this is the L. Okay, LZ tadi 2950. Okay, this is the value. Okay, sama the similar procedure. Masukkan nilai-nilai yang you dapat sama ada IZZ dan juga IZ. L. Okay, LZ. So this is the answer. Okay, the stiffness. Okay, the stiffness beam. Okay, this is beam FB. Kalau contoh lah ya, tadi ada saya cakap. Okay, this is the top. Okay, beam at the top, and then this is the beam at the bottom. Okay, and then this is our column. Seandainya, okay, seandainya size antara yang hijau dengan yang biru tak sama, you have to calculate untuk yang biru tadi. Because our case is yang FB is similar to the GB. So saya calculate the stiffness tu sekali saja sebab nilai size dia sama. Tapi kalau size dia tak sama, you have to recalculate. You have to calculate secara berasingan K untuk GB. Let's say the span, let's say GB5. Okay, this is numbering, and then span number 1, span number 2. Okay, you have to calculate separately. Okay, so this one, the relative column stiffness. Okay, this one, okay, kuat panjang juga dia punya ni. Saya bagi contoh satu. Okay, dua. This is the K, stiffness of FB5. This is span number 1, and then stiffness for span number 2. This is span number 2. Okay. So this is the answer. Okay. So greater than 0.1, so we use K2 sama dengan 0.19. Here we use K1 sama dengan 0.19 juga. Ini sama saja, equation sama, but you be careful of inserting the value. So this one we use K2 equal to 0.11. This is K2 equal to 0.11. Okay. So, we dapatkan semua nilai ni, and then barulah kita boleh kira dia punya effective length of the column. Okay, for brace column, kita masukkan balik nilai-nilai tadi. Okay, this one K1, K2. Jawapan akhir dia ialah 1913 mm. And then for the y-axis, jawapan akhir dia ialah 1810 mm. Okay, be careful kalau beam tu, beam di atas dengan beam di bawah, kalau sama size is okay, senang. Kalau tidak, the stiffness tu you kena kira semula. Okay, sebab you ada this one, you ada K ni lah, this one, K at the top and bottom. Okay, kalau bottom you katalah bottom you adalah GB, and GB tu size dia tak sama dengan FB, so you kena gunakan nilai yang GB tu. Kalau yang sama tak apa. Okay. Okay, so this is the radius of gyration. Okay, masukkan saja nilai-nilai ni. Dapatlah nilai this one. Okay, 108.3 and then 172.3. Okay, untuk y-axis. So, the slenderness ratio you can calculate based on this equation. So, the answer is 17.7 and 25. Okay, for Z and Y-axis respectively. Okay. Then we calculate the slenderness limit. Okay, based on this clause in Eurocode 2. So the value, the limit is equal to 20 ABC divided by N square. So ABC is senang je. Kalau kita unknown, kita boleh gunakan 0.7 untuk A, 1.1 untuk B. And then C kita kena kira sikit. Equal to 1.7 minus RM. Okay, RM is equal to moment at the bottom tadi bagi dengan moment at the top. So for Z-axis, jawapan dia negatif 0.41. So RM sama dengan this one. Gunakan equation ni, CZ 1.7 minus negative 0.41. So dapatlah dia punya answer. And then for the CY, kita akan dapat 0.12. Okay, I hope you can try by yourself. And then slenderness limit, sorry, apa pula datang ini? Okay, slenderness limit. Okay, so this one is FCD sama dengan 0.85 kali dengan 0.85 kali dengan FCK is 30. This one, gamma C is 1.5. Okay, the partial safety factor for concrete. So answer is 17. So value of N, okay, because we need the N here. So N is equal to 0.97. So the limit of Z-axis is equal to 33. Okay, you just enter the value of A, B, and C. Okay, for C, this you use CZ, and for Y you use CY. Okay, this one is 33, the limit. and then the actual is 17.7. So it's the column is non-slender. Okay, because it's still below the limit. And then the similar goes to y-axis. Okay, 33.1 the limit, larger than the actual. So it's also also non-slender. Itulah dia. Messi dah tak tampak triangle. Tak apa-apa dia sepak. Okay, this one is non-slender column. Okay. Non-slender column. Okay. So this one cara yang panjang. Ini adalah alternative solution. Ini cara yang lebih pendek. But we have to refer the table. Okay. So this one gunakan kaedah ni, kita tak perlu nak kira stiffness dan kita tak perlu nak kira kita boleh skip. Okay, by using this solution, alternative solution, we can skip the step of C, D, and E. Okay, we can skip these three steps. Okay, we calculate the end condition. Okay, is 1.0. This is also 1.0. You can read the situation here. The condition one, this is z-axis. Okay, z-axis. The end of column is connected monolithically to beams on either side, which are at least as deep as the overall dimension of the column in the plane considered. Okay, so the factor here, this is the end condition, bottom condition is 1, end condition at top is 1, so the factor is 0.75. Okay, so effective length is equal to, okay, this is we calculated before, the clear height times the factor, so effective length is equal to this one. Okay, and then for the y-axis, situation is similar, the condition is similar, so we can get the effective length is equal to 2269 mm. Okay, and then the slenderness ratio, just calculate. Okay, L 2213 divided by 10. Okay, so this is the ratio, and then this is the ratio ke limit ni. This is ratio, okay, sorry. This is ratio. The limit tadi adalah this is 20.4. This is lebih kecil daripada 33.0. This is the limit. Okay, this is the actual ratio. So this is also the non-standard column. Okay, and then this is 31.2 compared to the limit. Okay, the limit is 33.1. Okay, of course, if we are using this solution, alternative solution, the actual will be higher compared to the method which involve the stiffness and the moment inertia and so on. Okay, so the column is non-standard. Okay, so that's all for this tutorial. I hope you can try by yourself later. Okay, Dr. Rozaina, that's all. Thank you.
Alright, Alhamdulillah. Terima kasih Dr. Irwan. Okay. So, semua okey ke lagi? Okay, dah bau nasi apa tadi, Doktor? Nasi Arab?
Nasi biryani.
Okay.
Penalti sebelum pukul 12, okey lah. Penalti tak berlanjutan. Cukup 5 kali.
Itulah, Alhamdulillah. Just nice. Okay, Alhamdulillah. Terima kasih. So, sebarang pertanyaan, saya rasa kalau nak buka takut, macam mana Dr. Irwan kalau ada pertanyaan ni? Sebab kita dah pukul 12 kan?
Semua jelas kot ya.
Ada pertanyaan ke?
Nak tanya satu
Saya
dua.
buka 1-2 minit kalau Okey, cuma ada yang bertanya dekat saya. Okey, insya-Allah jelas. Thank you Anis. Okey, ada yang bertanya nak beli macam mana buku ni. So saya cadangkanlah. Saya kata insya-Allah saya akan buka open order. Boleh Dr. Irwan? Saya open order sebab kalau seseorang nak entertain takut banyak pula postage nanti kan. So kalau saya buka list dekat dalam kelas dengan lecturer lain yang berminat untuk ni, kita order ikut secara pukal lah banyak. So nanti mungkin boleh postage sekali buat je. Betul tak macam tu ke? Macam mana Dr. Irwan prefer?
Macam mana kalau saya boleh runding dengan, sebab yang dijanjikan dengan saya adalah paling cepat boleh dapat hujung Januari. Saya takut tak sempat. Dah hujung SEM kan?
Oh, I see.
Itu yang saya pun
So paling cepat paling cepat boleh dapat hujung
sebab
Februari.
sebab LO untuk penerbit deal dengan keluarkan LO bayaran semua pada syarikat cetak tu dia tak keluar lagi dah hujung tahun kan. Dah hujung tahun dia dah tutup account semua. Saya dah order banyak juga, tapi dia kata paling cepat dia buat awal tahun baru dia keluar LO semua.
So stok terkini memang tak mencukupi pilah ya?
Saya ada sikit je lagi.
Okay, so sebab kita final exam kita akan yelah budak-budak ni sutradara ni dia nak pakai yelah untuk final exam kan, revision. So kita punya exam akan bermula pada early February kan. So 6 February. So kalau sempat nanti tak apa, kita akan follow up. Kalau sempat nanti kita buat open order. Boleh doktor
Boleh lah. Kalau
insyaAllah. Kita cuba usahakanlah. Okay.
Sebab memang on demand juga benda ni, sebab dah ada 5-6 orang yang engineer, civil engineer yang nak buat PE, dia pun beli juga.
Okay.
Politeknik pun kata nak panggil nak buat meeting, nak minta saya briefkan juga macam ni.
Sorry, itu berdasarkan kewangan di UMP lah kan. Kalau kata kita dah ada duit, dah ada collection dan kita bayar, macam mana? Boleh cepat ke? Maksudnya dia based on
dia kena macam mana? Saya cuba tanya dulu dia penerbit macam mana kan. Kalau boleh duit tu macam mana tu susah juga boleh melibatkan sebab dia ada agreement kan. Saya tak boleh print di luar benda ni. Saya ada soft copy tapi saya tak boleh print di luar. Dia kena melalui penerbit juga.
Okay, tak apa. Nanti kita bincang benda ni, kita follow up nanti lah. Alright. So far ada persoalan lagi ke? Dah pukul 12? Ya, tepat-tepat pukul 12. Kita ada 5 lagi lucky draw ni. Ke tak nak lucky draw? Boleh je kita habis terus. Gurau-gurau. Nak. Okay. Dan tak ada persoalan, tak apa. Kalau ada persoalan, insyaAllah akan datang, boleh tanya dan kita sama-sama selesaikan bersama-sama insyaAllah. Kita boleh refer insyaAllah. Dr. Irwan tak ke overseas ke mana-mana, menghilangkan diri, tak ada kan?
Tak ada.
Tak ada. So kita boleh cari dia kalau tak ada. Kalau di isu sebelah sini tak faham apa-apa lah. Okay. So kita pergi ke lucky draw sesi yang terakhir. Alhamdulillah dah settle tiga tutorial dan saya tutup saya not accepting response anymore. Kita ada 152 responses. Okay. So kita dah exclude 10 yang tadi So sekarang ada 5 lagi. Mana saya punya ni sekejap saya share. Okay. Sekejap saya final check. Nama terakhir. Okey, betul? Okay. Alright. So saya share sekali lagi. Dah share? Alright. So bismillahirrahmanirrahim. Nampak Okay. Nama yang pertama untuk sesi yang ketiga. Okay, Nur Syafiqah. Ada ke?
Ada.
Ada. Ya ke Syafiqah? Tak apa buktinya? Sebut nama bapa.
Barusya.
Terang-terang lah tahu kan. Okay. So Nur Syafiqah. Okay, sekejap saya screenshot dulu untuk kita ambil detail. Okay. Alright, Tanya. Okay, yang kedua. So saya remove. Next. Bismillahirrahmanirrahim. Tiup. Maisara, Masya Allah. Ada ke Maisara binti Zulkarnain?
Ada.
Ada?
Ada. Dia kakak.
Ada. Okey, alright. Ada okey. Okey, Maisara. Okey, yang ketiga. Bismillahirrahmanirrahim. Siti Aida Husin ada ke? Siti Aida 1. Siti Aida 2. 3. 4. Okey. Dekat chatbox ada tak? Kita tolong doktor tengok kan. Doktor Nadia ada tak? Tengok tadi dekat dalam chatbox. Okey. So tak ada. Kita
Ada Rozaina.
close. Sorry, tak ada Okey, saya close Close ni close.
Oh, ada.
Okay, kita
Dia
remove.
baru reply.
Ada
Dia baru reply.
Okey saya. Okey, alright. Saya baik. Itulah mata rezeki. Mana saya punya tadi? Okey. Siti Aida, saya tengok. Siti Aida. Okey. Siti Aida. Okey, next. Bismillahirrahmanirrahim. Masya Allah, nampak tak kalau ada rezeki Khairul Azman, tadi nama dia naik tau. So dia pergi toilet. Ada tak Khairul ke tak ada kat kali ni? Kalau tak ada tu memang tak boleh cakap apa dah. Khairul. Serius lah. Khairul 2. Khairul 3. Tadi nama dia dah naik. Lepas tu dia tak ada. So kita exclude. Tak ada. Okey, tak apa. Memang
Tak ada rezeki,
dia lah. Okay. Yes, exactly. Percaya pada rezeki Allah. Okay. So kita remove. Bismillahirrahmanirrahim. Next. Yang tak muncul tadi sebenarnya kita masih include nama dia. Sebab dia pergi toilet kan. Kita maafkan lah. Tapi tak ada rezeki lah. Dia tak ni. Dia tak
Dia baru reply.
Okay, I know.
Khairul Azman tadi.
Okay, tak apa. Kejap. Ainul Akila ada tak? 1, 2. Ainul Akila?
Ada doktor.
Ada okay. Ada, remove. Okay.
Jom.
Okay, next. Ainul tutup suara sayang. Okay. Celestina ada tak? 1, 2, 3, 4, 5. Tak ada. Dekat chat box ada ke?
So far tak ada.
Alright, so far tak ada. Okay, so next. Tiup. Alright. Nabihah Zafran. Ada ke? Nabihah 1. Nabihah 2.
Saya doktor.
Nabihah 3.
Saya doktor.
Nabihan, sorry. Okey, Nabihan ada Okey, alhamdulillah. Sorry Nabihan.
Ada.
Lepas tu dia tak bersuara. Ada Okey. Remove. Okey, 1, 2, 3, 4. Kejap. 4, satu lagi tadi kejap. Siapa? Khairul Azman dia kata apa? Dia prepare abang dia sanding. Gitu loh mak. Masya Allah. Sibuk betul dia. Tak apa. Kita abaikan kejap Khairul tu. Boy. Dia kill tu. Dia keluar berjalan. Keluar merata pergi keluar dari kelas. Tak mau kita abaikan dia. Okay, next. Tak apa student saya tu. Yang kelima yang terakhir Khairul Azman kita biar pick ada Azad. Sebab ada something. Okay, next. Muhammad Syafiq Hasrul. Okay, alhamdulillah. Ada tak Muhammad Syafiq? Muhammad Syafiq?
Ada.
Apa bukti awak Muhammad Syafiq?
Macam nak buktikan
Asian dia. Tak apa. Macam ni. Kita apa kita percaya. Okay, thank you Syafiq. Alright, okay, alhamdulillah. Okay, thank you. Alhamdulillah. Sudah selesai kita punya lucky draw. Ada 10 hadiah yang kita akan bagi nanti. Biarlah rahsia kan. Biar Allah, orang yang memberi tahu, orang yang menerima tahu. Yang lain buat tak tahu je lah Okay, so 5 hadiah. Mana Khairul dah merajuk dah? Okey, tak apa. Sebenarnya memang saya ada satu allocation untuk hadiah hadiah yang sama untuk pelajar yang masuk paling awal dalam kelas. Yang masuk paling awal tadi pukul 9. Masa dia adalah pukul 9:09:27. Lepas tu next dia 9:09:58. So siapakah orang yang pertama? Deng. Itulah kalau dah rezeki tak ke mana kan. Mana Khairul tadi? Alhamdulillah. Khairul adalah orang yang pertama masuk kelas hari ni. Khairul Azman bin Muhammad Syarif. So memang ada je lah untuk dia juga sebenarnya. Okey. Dia sebab tak tahu je tadi. Okey, Khairul maju ke? Ada nak dengar suara kali ni? Okey, ada. Okey, so ada 10 campur 1 hadiah kita. Okey, so settle untuk itu. So kita dah 3 jam 10 minit bersiaran, Masya Allah. Okey. Alright, so saya rasa tak ada apa-apa lagi. Kita mengucapkan terima kasih sangat-sangat kepada Dr. Irwan. You all tahu tak nama glamour Dr. Irwan apa? Dekat dalam buku dia ada tahu. Siapa tahu? Pak Irwan. Tak tahu. Okey. Nama glamour dia Pak Irwan. Okey, bukan PAK the special sikit agent dia PARK. Park.
Siapa nak sign saya sign buku.
Siapa nak sign? Park IR-1. Pak Irwan. Okey. So nama glamour Dr. Irwan. Okey, so terima kasih banyak Dr. Irwan sebab sudi menjadi tetamu kita hari ini, menyampaikan insya-Allah semoga segala ilmu tu bermanfaat untuk pelajar kita. Dan Dr. Nadia sebagai koordinator subjek ini, dia nak cakap apa-apa ke sebelum kita tamatkan dan kita ambil gambar sikit sekejap lagi? Ada ke? Nak cakap apa-apa Dr. Nadia? Betul.
Assalamualaikum. Terima kasih banyak-banyak Dr. Irwan kerana sudi menjadi speaker kami ya. Quite last minute juga ya kita invite.
Tak apalah, mari saya boleh buat slide saya sendiri.
Itulah.
Terima kasih lah.
Terima kasih untuk ilmu yang diberikan kepada student-student UiTM. Semoga student-student kita faham lah ya. Dan semoga kita boleh bekerjasama lagi di masa hadapan.
InsyaAllah. Terima kasih. Baik.
Alright. Okay. So,
ada kelas.
Okay, kita mulakan sesi gambar kita, boleh? Mari masuk duduk sila. On camera.
Student, please on your camera.
Tolong sayang semua. Okay, seorang dah masuk. Ini memang peserta paling awal dari tadi. Asyik buka kamera. Okay, thank you. Lagi-lagi, penuhkan seat tu. Sila. Siapa kat sebelah saya ni? Hai. Okay, next. Lagi cepat. 1 minit, 2 minit. 1 minit, 2 minit. 1 saat, 2 saat. Mana yang perempuan-perempuan ni? Yang lelaki, had lelaki patut piawai ni, sembahyang Jumaat ni, pergi bentang tikar sejadah. Mana yang perempuan? Lagi ada seat kosong. Oh, yang tu share ni. Share kamera, share laptop, terpaksa share tempat duduk lah nah. Sorry. Cepat, kita tunggu lagi beberapa second. Dah ready ke? Okay, tak apa. Nanti kita freestyle. Kita buat formal dulu. Ada lagi banyak seat kosong tu. Kita ada sekarang dalam kelas kita 156 orang. Okay. Seat ada 160. InsyaAllah cukup. Okay, dah Ready? Saya nak screenshot ni. 1, formal. 1, 2, 3. Okay, kejap. Yang pakai mask tu tak mau buka mask ke? Okay. kita bukan dalam kelas real, kita online kan. Okey. Satu lagi. Satu. Tengok depan. Dia sempat lagi menegur kawan sebelah. Okey, satu. Masih lagi formal sekali lagi. 1, 2, 3. Okey. Okey, yang ini freestyle. Yang ni freestyle Okey. Satu. Apa lagi nak buat Mini love. Siapa nama yang depan saya tu? Siapa? Lindunglah muka saya. Turunkan tangan. Janganlah sini masuk juga. Yes, macam tu. Okey. 1, 2, 3.
Nampak.
Boleh tak?
Okey.
Alright. Okey lah. Sekali lagi freestyle. Okey, sekali lagi freestyle. 1, 2, 3. Dr. Irwan pegang buku dia. Okey. Alah, kejap. Siapa muncul tiba-tiba kat depan ni? Sekali lagi Dr. Irwan.
Okey.
Pegang buku. Okey, sekali lagi freestyle. Sebab tadi tiba-tiba gambar ni. Okey, 1, 2, 3. Okey, cantik. Alright. Cantik, siapa yang cantik? Okey, Alhamdulillah, terima kasih banyak. Semoga semua orang dalam rahmat Allah, dalam lindungan Allah. So nanti sambung lain 10 lagi ayat Al-Mulk, surah Al-Mulk tadi kita dah buat 10. So 10 ni kita sambung sendiri. Okey, so terima kasih sekali lagi Dr. Irwan, Dr. Nadia, Dr. Balkis ada dan pelajar-pelajar daripada Unimed, Dr. Nur Baila daripada Politeknik Podikson. Okey. Dan ex-student kita juga, ex-student PhD kita. Okey, terima kasih semua. Okey. Alright. Assalamualaikum. Nanti kita akan share balik video ni.
Thank you, Dr.
Thank you. Assalamualaikum.
Thank you, Doktor.
Thank you, Doktor.
Terima kasih, Madam.
Thank you, madam.